So in this video, we're going to talk about the idea of the dihydroxylation reaction. Now we have two types of these reactions. We have an anti-dihydroxylation, and we actually have a syn dihydroxylation. Excuse me here for my bad handwriting. Now the idea is that without showing any stereochemistry, the idea is that if I take any alkene and I do this dihydroxylation reaction, this is the product that I should expect. Right? I get two OH, in other words, dihydroxylation across the double bond. So that's the gist of the reaction. Now let's go down into details with respect to each. So if we look at A, the anti-dihydroxylation, it actually requires two steps. It actually requires two steps. The first one is you want to make an epoxide. You want to make an epoxide, and we actually typically make an epoxide using what we call a peroxy acid. And I'm going to show you what that means in a minute. There's a peroxy organic acid. And the second step you want to follow with respect to anti-dihydroxylation is that we actually do the ring opening. So we actually ring open the epoxide with either an acid or a base. So the anti-dihydroxylation reaction requires these two steps. So let's look at what we're talking about. So if I take this common alkene, this is cyclohexene, and I add this molecule, the R group is just anything, right? But this ester directly connected to an OH group, anytime you see this is a peroxy acid. And this is what we call a peroxy acid. So we do this in the first step to form the ether, right? And in this case, we're going to get something that looks like this. Or we could get the opposite. Right? Either or. So this, ladies and gentlemen, is creating our epoxide. Now remember, we said the second step we open it with a base or acid. So in this case, we could just take OH minus. We attack the carbon containing the oxygen, and we displace the electrons on the oxygen. That gives us a negatively charged oxygen. Now this goes down to the second carbon below. So in other words, the intermediate that I'm looking at is something that looks like this. Remember, since the OH group is the epoxide is coming up or out of the ring, that means that the OH minus has to attack from below. And so with that case, we should have something that looks like this on the first carbon. But remember now, we said it's anti-dihydroxylation. And so notice that we're saying that the OH group and the other OH group with respect to each other ends up on a different sides. So they should have different stereochemistry. If one is going up, one should go down. Or if one is going down, one should go up. In the last step, we pretty much just add another molecule of water. The OH group attacks and displaces the electron on the oxygen. So our final product should be something like this. So the mechanism is not what I want you to worry about. Is the idea that if I take a peroxy acid, I form the epoxide, and then I open the ring up with an acid or base, and I essentially get the oxygen groups or the hydroxyl groups on the opposite side of the double bond. So that's the idea of anti-hydroxylation. Now, a key molecule that I need you to remember for anti-hydroxylation, and this is actually what we call MCPBA, and this is, you'll typically see it in organic chemistry. This is what we call meta-chloroperoxybenzoic acid. This means anytime you see MCPBA in H3O plus or in acid, that means that we're doing anti-dihydroxylation. Right. So the typical reagent for this reaction could be MCPBA with acid. Now the second one is the syn dihydroxylation, and this one actually uses osmium tetroxide. So you'll typically see this reagent, it is called osmium tetroxide. So if I take again cyclohexene and I add in the first step osmium tetroxide, in the second step NMO, then I actually get again dihydroxylation, but they're on the same side. So this is the product that I get, and I get the enantiomer. And the enantiomer is simply the opposite. So now I'm gonna, one of the OHs are gonna be, both OH are gonna be coming up at us versus going away. Right? Again, if I take another alkene, such as this, I add in the first step osmium tetroxide, and the second step NMO, I should get this as my product plus the enantiomer. And the enantiomer is simply, again, both OH is now going away from us instead of coming up at us. Right? If I take this molecule and I add MCPBA in the first step and then acid in the second step, pause the video and predict the products. Right? I should get something that looks like this. Again, anti-addition or anti-dihydroxylation.